think that that is indeed a very interesting distribution. Would you expect the same, Luca, to have the similar results in the top 3?
I'm actually surprised by the unique storyline, but I guess it makes sense. And yeah, of course, I mean, improved skills and strategies, like especially for like strategy-oriented games, it's always like sometimes you just don't know what to do, right? And so having something that helps you along the way is actually really nice.
Yeah, indeed. All right. That was it from my side on having a small warm-up and reviewing where we are standing. And now we are pretty much handing over to you, Luca. When it comes to the setup of ours, we have decided that you can ask questions during the presentation. You can. I have seen that someone of you doesn't have the access to the microphone. You can drop them into the chat. I will be able to see that. On the recording, though, we won't be having the chat. That is why I will also read the question then out. But I am now stopping to share my screen and passing over.
Okay. Let's see if everything works. So I prepared like a gazillion slides and I have 20 minutes. So that's not going to work out, but we can make it work. Some overlay is showing on my screen. Can everybody see the screen so far?
A digital assistant for
Perfect.
EliteDangerous.
Okay. So, about a year ago, roundabout, my boyfriend and I were having a bit of downtime, a bit of slack time to do the things that we wanted to do. And my boyfriend actually really likes to play this game called EliteDangerous. I'm going to talk a bit about that in a bit. So we decided, because we previously looked at a lot of other solutions, other games that used like some kind of AI aspects, like mods and integrations that were third party to the game. And we were like, well, this game actually, it makes a lot of sense to have an AI integrated into this game. And so yeah, half a year ago, the first commit was made into our EliteDangerous AI integration repository. And up until today, in the last 14 days, we had 240 downloads of our application. That is like a standalone application that you can launch alongside the game. And yeah, and then you basically just give it your OpenAI key and it's just going to work. So let's get started with that. So first of all, what is EliteDangerous? EliteDangerous is, I don't know if anybody of you knows the original Elite game. That was one of the earliest computer games with 3D graphics, lots of wireframes and so on and so forth. And the game has evolved quite a bit. Nowadays, the latest release is the EliteDangerous one, where you have the entire Milky Way to explore. So there's a gazillion of systems that you can travel to and explore, and it has a bunch of different features built in, like trading, different missions that you can do, power play, politics, and so on and so forth. Lots of exploration, right? Because there are just so many star systems around. You can do asteroid mining, and you can also do combat. So I just brought two of the screenshots that I liked. This is basically how it looks, and you can imagine it sometimes gets a bit lonely in the game, right? So also my boyfriend loves to play this with family, but they're not always around, not always when he has time, right? Because of work and so on and so forth. But he still likes playing this game, and so yeah, we were like, okay, we can maybe help out with like some kind of AI integration with this. So what we built is called Covas Next. Covas is actually already the ship computer inside of the game. So you're flying around in your spaceship in the game, and you have the ship computer that is called the Covas. So we decided we wanted to build the next generation of this Covas ship computer that is now AI powered with like text to speech and speech to text. And it's basically a voice assistant that helps you inside of the game. So what you can, for example, I gave two examples here. what you can say is navigate me to the Vega system. And the assistant is going to do it for you and then actually confirm what it has done and talk to you about it. Or if you're doing a mining operation or a mining mission, you can ask, oh, for how much can I sell this stuff? And it's going to reply to you, well, tritium, which is what you currently are mining, and it knows all about that, sells for 55,000 credits in the nearby markets. Because it actually has all the knowledge, all the environment that you're currently in, it has that in its context. So it can respond to you just in time in that situation and is very aware of what is going on around. So yeah, how does this work? So in the middle here, we have our Covas Next integration, which is, like I said, a standalone application. And we have the game that is running alongside. And what we can do on our side is we can essentially send keyboard shortcuts into the game. And at the same time, the game writes a log file with a lot of JSON events inside of it that basically then inform us about what is currently going on in the game. So for example, if you retract your landing gear or dock at a station or something like that, land on a planet, whatever, it's going to show up in the event log. And this is what we're going to read. That's what we're going to turn into like some game events inside our system. Then we're going to feed it into the context of the LLM. Basically send all of this to OpenAI, get a response back, and use text-to-speech to then play it back to the user. And the user can also just talk to the system, right? So we use speech-to-text, the microphone input with like push-to-talk or activity detection. And we're going to use speech-to-text via OpenAI again to turn this into text, send it to the LLM with all the context, all the knowledge about the game that the assistant has built in. Additionally, we have like a lot of functions like web APIs for example, market research and so on and so forth, because every station in the game has a different market. And they all have different prices and they change all the time because it's a huge economy. And so yeah, the AI can decide to look up certain things about the game and then inform the pilot about what is actually going on, like for example, the prices for tritium. So yeah, I think this is being recorded, right? Somebody asked in the chat.
Yes.
I think it is. So how does it look inside of the prompt? So basically, everything that is happening basically goes into one giant prompt for the LLM. We first of all have some bit of instruction, like what is the game that we're currently playing, we're role-playing in EliteDangerous, and so on and so forth. Then we have a customizable character that the people that are using our integration can actually put into like a text input field where they can describe how they want their AI to behave. If they wanted to swear, if they wanted to be rude or polite, if they wanted to like, if they don't like mining, then they can tell the AI that it also shouldn't like mining, and it's going to comment about like, we're going to do mining again, I hate this, and so on and so forth. So they can really customize a lot about the character of the system. Then we have a bunch of tools, like 33 tools in total, that perform different actions on the ship, all the APIs, and so on and so forth. So it's a really long list of different tools, different actions that the model can decide to take. And now for the majority part of the entire prompt is we have a lot of like situational information about what is going on in the game. Are we currently flying a ship? Are we walking on the planet? What is the cargo capacity that our ship has? Are we under attack? Is there an enemy nearby? Is there a planet nearby? Is there a station nearby? And so on and so forth. All these informations we are going to store inside of the prompt as well. And then there's also the dialogue. So whenever something happens inside of the game, we're going to call it a game event. And for certain game events, we are going to then trigger a response from the assistant. So you can select which events you want to have a reaction to. So for example, if you docked at a station, this is an event that happens. And as soon as this happens, we're going to send all of this to OpenAI and get a response from the system that we're going to read out. And so it's going to comment about all of the events that happened up until that point. The second kind of dialogue that we have in there is tool requests. So basically, you can command the AI to, for example, toggle the landing gear, and then it's going to make the tool request to toggle the landing gear with the parameters that it's going to need. We're going to then feed back a tool result into the prompt, and then we're going to get a assistant response saying something like, okay, I have retracted the landing gear. Then we also have open questions like, what is the best equipment that I should use for mining? So there's like some kinds of equipment that you can buy. These are just general open questions about the game. So the model needs a lot of knowledge about what is actually going on in there. And we have closed questions like, what's my current cargo capacity? And this then goes back into the situation awareness that we have put in the prompt, so it can answer those questions about your current ship, your status, and so on and so forth as well. Okay. I'm really low on time. Jesus. So for our roadmap, we have a lot of things that we still want to do, right? It's been only like half a year of development so far. And as I said, this is a pet project, so we're only going to do this after work and in our free time during our holiday and so on and so forth. But we have a lot of fun doing it, so at least there's that. And yeah, there's a lot of things we can do. We can, for example, improve the search for certain materials or stations and so on and so forth. There's a lot we can do in that regard. We want to actually put a lot more actions into the system so that it can do even more things. We already have 33 different actions it can take, but we want to do more in that regard. We can improve the state management. We want to use a knowledge graph so that there's less hallucinations about like certain things, that certain mechanics in the game, so we want to ground it a bit more. A lot of game lore that we want to maybe like contextualize and retrieve on the fly as soon as you start talking about some of the history of the universe that we're currently in and so on and so forth. We might want to include that into the prompt, again, to ground the system, to give more reliable answers. And one thing that I'm going to talk a bit more about is actually, we would love to be able to get this to run locally. Currently, we're using OpenAI exclusively. And to be honest, it works amazingly well. These models are incredible, especially if you have like 33 different actions. They almost always choose the right one. They almost always strictly follow the arguments that are supposed to go into these tool goals. They barely ever hallucinate, and it's actually really impressive. But we can try, right? This is a pet project, so there's no requirement for something to work. We don't have to like invest a huge sum of money into something where we're like, oh, if this doesn't work, oh no. This is our free time. As long as we learn something, it was worth the investment, right? So this is the nice thing about why I even think this is like the perfect pet project to have. We have actual users that are using our application, and we do it for fun because we really like doing what we do, and there's no risk involved, essentially. So let's talk a bit about what we do to get local. So essentially what we need is a system that is able to perform speech to text, that is able to handle the large language model, and also run text to speech to read out the answers, right? We have a lot of different fields that we need to address. For example, we needed to adhere to the character. We needed to have at least some game knowledge so that it doesn't hallucinate as much. We needed to understand the events that are coming in from the game. We need to have it contextualize everything. We want it to be incredibly multi-turn because there's a lot of history and references to previous questions and previous actions that are relevant to give a good answer. And this is probably the biggest thing, we need to have incredible, reliable tool calling. Three of the things that are in our way, or the challenges that we're facing, is like we need really high quality, which is always a challenge if you go smaller with the models that you're running. We need really low latency, which means that we need really fast processing of everything. Because if you ask a question and it takes 30 seconds to reply, that's no good either. And we are really limited by hardware. And yeah, I can talk a bit about that. So yeah, let's talk a bit about hardware. So say a player has a graphics card with 12 gigabytes of VRAM. Then we would need to at least dedicate 8 gigabytes of that to the game. Which means that effectively we only have 4 gigabytes of VRAM left for the model and the context. Additionally, in terms of compute, we want the game to be running at 60 FPS. And we want to perform at least 1,000 tokens per second for the prompt. So because our prompt is getting longer and longer, like 1,000 tokens per second means that for one question, we have about 6, 7, 8 seconds of prompt processing if we are at 1,000 tokens per second. So the latency is going to suffer a lot if we have less performance on the prompt processing. So 3 of the local options that we have for this is, of course, the Llama models. The Llama 3 models are really, really quite good. And so if we were to look at, say, Llama 3.21b, this is actually a good choice. It fits all the criteria. Maybe not quite the 1,000 tokens per second, but that highly depends on the graphics card, right? But the 3B model is already getting close to the 4 gigabyte limit that we have here. And the 8 billion parameters model is definitely busting that. So we cannot even go up to 8 billion. We need to be smaller. So there's a few technologies, few developments. I will talk about quantization a bit. Good question. There's a few things that we can do to improve this. For example, we can use prompt caching because most of the prompt stays the same. We don't need to reprocess that. We can just process the tokens that have changed, which makes it a lot less to process, which reduces the latency. We can use quantization. In our case, we use the Q8_O GDUF quantization, just to answer the question there. We needed to adhere to JSON schema. So essentially, the models can adhere to a given structure for the arguments of, for example, functions. So this will guarantee that the arguments are always of the correct type, and there's always the required arguments are always in the tool use calls and so on and so forth. So this also helps a lot, and this is a requirement for us to have because we need to be very reliable in these tool calls. And we needed to run on CPU, NVIDIA, and AMD. So the tooling that we choose to run all this on is Llama CPP because it perfectly fits all the criteria. So before we train anything, we need to collect evals. So basically what we did in order to collect at least a bit of references that we compare other models against, we basically just let my boyfriend play the game for a while. And in the meantime, I'm going to tell him, well, use different kinds of interactions, like use tool calls, open questions, close questions, let it react to events. Tell me if there's anything that you didn't like, and I'm going to take note of it, right? And I'm I'm going to record all the requests, and he's going to send me the database over afterwards. And then I'm going to go through them and label them according to which category they are, if that's an open question, if it's a reaction to a game event, or if it's a tool use or a command. And because I also recorded the answers that the model actually produced, and because the OpenAI models are just incredibly good at this, we also store this as our references to compare against. So we have those 4 categories, and we have the reference responses that are GPT-4o. And this is basically our eval dataset from that point on. Next, we're going to use LLM as a judge. So basically, we're going to use all these examples and the reference answers, and we're going to ask an LLM if the model that we're currently evaluating against has a close enough answer according to some categories. And the categories that we choose in our case is prompt adherence, which means how much in character is the response that the model has given compared to the GPT-4o response, right? So we have something in there, you only answer in a single sentence and you use swear words or something. Then the question is, does the student model also do this? Then we have a metric for event context. How much of the surrounding information that we put in the prompt is actually used in the answer? How good is the model at like contextualizing what is currently happening with the things that happened in the past? Then we have like the baseline hallucination, which is like, you don't make things up. Don't invent anything new that isn't provided in the context. And we also grade on that. Then we have a metric for tool choice, which is not actually LLM based, but just hard coded if it's the correct tool that the model used. So when there's a command given, we wanted to use the right tool at the right time. And then we have tool arguments. If it then used the contextual information to provide the tools with the correct arguments to say filter for certain stations close to your current location. What's your current location? Well, it's somewhere in the context, so the model should know, right? So now let's actually look at some of the results. We tested the baseline models for Llama 1B, 3B, and 8B, and also GPT-4o Mini, because why not? And this is basically what we measured. So in terms of prompt adherence, what you can see, well, the 1B fails in like most of the time, or not most of the times, but actually quite a lot. And it gets better the smaller the model, and GPT-4o Mini almost nails this task. In terms of contextualizing and like reacting to events, we see the same thing. Hallucination, same thing again. For tool use, we also see, well, the 1B model actually barely ever makes the right choice when it comes to tools. The 3B model also barely ever does it correctly. In this case, like out of 24 examples, it only did the right thing in 5 samples, which is very little. The 8B model is doing slightly better, and the GPT-4o Mini, of course, makes it. And then in terms of if the arguments are correct, this is actually looking pretty good. There's not too much wrong arguments. And even the ones that are incorrectly added here, I would say sometimes I would say it's actually okay what the model has done in those cases, because sometimes it is okay to omit certain arguments. Oops. There. So I asked ChatGPT if we should do fine-tuning. And ChatGPT said that you should fine-tune a large language model when you need it to perform well on a specific task, domain, or dataset that differs from the general data the model was initially trained on. So in our case, we have 3 different tasks that we want the model to perform. So that's not good. The data set that differs from the general data the model was initially trained on, yeah, actually, all these models are trained on tool use. They're trained on questions and answers. They're trained on commentary. So does it really differ? No. We could argue that maybe we could say that this is a special domain that we want to train on. But then again, that's also kind of boring, and we may change things in the future. We may want to use these models for other things. So let's ignore that for now, because it's just more interesting to fine-tune a model. So let's train a general purpose digital assistant anyway. How much time do I have left, actually? I think about 5 minutes. Maybe less.
You were still having 5 minutes.
Enough? I'm pasting the link everywhere. Okay, so what are the goals with fine-tuning here? We want the model primarily to talk less, because ChatGPT tends to be very verbose. It tends to almost always answer with a question in the end to boost engagement, which is kind of annoying at some point. We want to standardize the tool use, because the Llama models actually don't have a standard way to call tools or to use tools. We want the tool use to be much more reliable. We want the responses to still be informative. We want it to be multi-turn. And for now, we're going to ignore the adjustable character. We're just going to train it on one specific character, and we're going to later add in adjustable characters with the variety of responses, depending on the style that somebody would want. And we're going to completely ignore game knowledge, because fine-tuning is just not good at knowledge transfer. And we're also going to ignore humor. So this is like with the adjustable character, we're just going to not train on humorous commentary and so on and so forth. Even we want our assistant to be fun, especially in the game, but it is kind of hard to judge humor. So we're just going to leave it out for now, at least. There's a question. Can system prompt address some of these challenges? Definitely. Oh, the camera is not doing great with the focus. Come on. So definitely, the system prompt can definitely help. With all of this, especially if you have a large model. So, for example, the GPT-4o model is really, really good at this. So whatever you put in the prompt, it's basically just gonna follow straight. But small models, especially like already GPT-4o mini, sometimes struggles. If you put a lot of context into the prompt, if you put a lot of different styles and behaviors, if you make it really complicated in terms of character design, then the 4o mini already struggles a lot. And I need to somehow make the camera focus again. It doesn't like doing that.
Yeah, sometimes cameras do that.
It doesn't want to focus. Let's switch cameras then.
Oh yeah, that looks wonderful.
It's not the best camera, but it should work. Okay. So let's go back up. So how we are going to get the training data? We could, for example, collect training data from players, which is something that we don't really want because of privacy concerns. And also, most players actually use ChatGPT or GPT-4o as the model, and OpenAI doesn't want you to train on their model output. I'm going to respect that, so we're not going to do that. We looked at existing data sets for these kinds of interactions, but we also couldn't really find one that was a perfect match. We had a couple of data sets that were closely related, but none that were like just what we are looking for. And of course, we could do human labeling, but we don't neither have the time nor the money for that. So that's also not an option, and it's also kind of boring. So let's go for the technically challenging option here, and let's build a huge data set within synthetic data. And the big problem, of course, is data diversity. So there's a few things that we're just going to assume that we can use to introduce more diversity. And this is, for example, a digital assistant, which is what we want to train here, could actually work in any profession. We can pretend that the assistant can do things that it actually cannot physically do in the real world, right? Because we're just going to synthetically generate some responses that it just did something which it actually cannot do. Which also fits the kind of futuristic theme of the game as well, right? So this is a good assumption that we can make. And existing models know a bunch about common domains already, right? So if you're going to ask the model about like the dentist profession, then it's already going to know so much about it because there's so much online. And additionally, we can sample common professions and random names from static lists. And we can introduce these into the synthetic data to introduce more diversity into the samples that we're generating. And I'm actually going to skip a bunch of slides now. So what we did is we started out with the 100 professions. Like we just Googled, give me the top 100 professions in the world. And we had a list of 100 professions. And then we started out with like, for each professions, we had the model generate 10 processes inside this profession, right? This gave us 1,000 different processes that we could then work with. And for each of these processes, we let the model describe one work situation with like 10 random names included in it. So for example, who's the protagonist? And this would be one of the names. Like then who are the 5 clients? And then we would build a huge story out of this and then turn the story back into JSON so that we actually have like a condensed representation of this whole situation, like how's the building, where is it located, how many people are there, how many people are in the waiting room, for example, for the dentist. And we also generate like 6 different tools that some digital assistant may use inside of these processes, right? So because all these processes have different tools and need different tools, we let the model synthesize 6 different tools definitions and 10 different events that happen inside that domain. And then we go on from there. I'm just going to skip a bunch of slides here. And actually then generate the tool requests, the responses, and so on and so forth from those seeds, essentially. Generate events from it, like a logical sequence of events that we can then train on. And so this is what we did. We did the training, and I'm just going to look if I forgot something. No. So let's look at the results after the training. So the first thing we did is we trained a Llama 3B model. And the Llama model was already fairly good at what it was doing when it comes to like commenting on events, tool use, and tool responses. Notice that I have filtered our evaluation data set for these 3 specific tasks, right? Because the other 2 with open question, game knowledge, and so on and so forth, that's not something that we have in the training data, so it's a bit unfair to judge the model on that. So as we can see, even though the sample size is fairly small, but we can definitely see like trend that the model got better with the training. Especially in terms of hallucinations, which I really like, right? So in a lot of cases, it reduced the hallucinations, and actually it reduced the hallucinations to a level that is competitive with the 8B model, which is really cool. Tool use is even better. So the model actually learned a lot of tool use here. Previously, it only got a couple of tools, right? But now it's getting a lot more tools correctly added into the prompt. Again, almost competitive with the 8B model. And in terms of arguments, it also got those mostly right. There's a few more incorrectly added. I specifically looked at those, and they're actually not too bad. These are the kinds of things where you would argue it actually is okay to omit a certain information that the reference had in it, but it might be okay to ignore it. So actually, the model here is also doing fairly well. Then we also trained a 1B model. And I think here the contrast is even more stark. So while for prompt adherence, which is something that we not specifically trained on, it got a little bit worse. But again, this is basically how much does it follow the character that is in the prompt, right? And we did not train anything on character. So this is kind of to be expected. In terms of event commentary, the baseline got a bit better. It not necessarily got better overall because there's a lot of like slightly questionable answers here. But I would say it stayed mostly the same. And again, hallucinations dropped by quite a bit, which is also really nice. The poor responses are now actually same with the 8B model. But now let's look at the tool use compared to the 3B model. Sorry, this is compared to the 3B model. The tool use is even more crazy, right? So while previously it only got 2 examples in our evaluation rate, it now actually easily outperforms the baseline 3B model, which was really exciting to see. And in terms of the arguments that it used, they're also mostly correct, which was nice. Let's quickly talk about the bad. Because if we look at the open and closed question and answer pairs, the ones that we did not train on, right? Then it got a lot worse, obviously. It's not included in the training, so we would expect the model to get worse in these regards. So hopefully, once we include samples for these kinds of questions, the performance is also gonna get better, or at least stay comparable. And now let's talk about the ugly. I'm gonna zoom out a bit. There's a lot of things that we can improve on here, right? So somebody already previously said, how much can we do with prompting, with the system prompt? Probably a lot. We have not really explored this area too much. Now that we have proper evaluations, we can actually tweak the prompting a lot more and steer it in certain directions and so on and so forth. So we definitely need to explore that a bit more. As you've seen, our eval sample size is not too large. It actually takes quite a while to collect these samples, to label them, and so on and so forth. So we have not prepared every sample that we currently have, but it's still nice to have at least something that we compare this to. So I think it worked out for us in this case, but we definitely need to increase the sample size. Tool templating is another thing. Like, how does the model actually call those tools? Are there different templates that we can use, different formats that we can use, where the model gets better or worse at tool calling? This kind of goes into the prompt engineering, but actually goes one level deeper into the underlying chat template that is used to denote the different characters in the chat model. The data set diversity is definitely something that we need to improve. I looked through a couple of these samples, and they basically usually start with roughly the same few words. Then they diversify as they go along. So this is something definitely that we need to look at. We only use one model for all of these tasks. Why do we do this? I don't know. We could use different models for different tasks, right? But then we need to train some kind of routing mechanism that detects if it is an open question, if it is a tool use, and so on and so forth. This could definitely be something that we can explore. And this would also help us with use case specificity. Why did we even train a general model in the first place? We only have the EliteDangerous integration to worry about, right? So the domain can actually be much more specific than we actually trained on. But this would give us a huge boost, so there's a lot of room for improvement here. And the evaluation method. We currently compare two GPT-4o answers, and we're using GPT-4o to judge these answers. There's a certain bias for these models to prefer their own answers. So obviously, it's going to love the responses that the 4o Mini has given, and it's not going to like the Llama ones. This is just an inherent bias that these models have. So there's a lot of things that we can improve in that regard as well. Use multiple different models as the judge, or even train our own. Can you leverage an agent architecture for tasks that understand what model tools needed per task? So we actually use some kind of agent system. This is like some of the tool calls have another LLM call in the background. So for example, there is a news feed that we can query, and then we're going to use another model to summarize the news feed with regards to certain questions and so on and so forth. And we're going to feed that back into the main model to then read it back out to the user. So there's a lot of potential for different agentic approaches. We just have not explored this too much yet. And like I said before in our roadmap, these kinds of knowledge graph systems and so on and so forth, if we were to include them, those would definitely be more agentic than what we're currently doing. So I guess it still works, which is actually kind of surprising. When we set out to do this, we were like, yeah, let's just try this. It may work. We're just going to do everything wrong, essentially. We're going to not use a specific domain. We're going to use really small models here. We're just going to not use any real world data. We're just going to only use synthetic data. And yet it kind of works. We tested the model in the game itself, or at least my boyfriend did. And we said, well, it's actually, it's usable now. And the previous 3B model without the fine tuning kind of wasn't. So there's definitely some improvement there, and we can definitely take this a lot further, and we probably will. Thank you so much.
Thank you, Luca. Thank you so much. I will be also clapping. I have seen already a lot of people clapping. And we should also be clear on the point that now your boyfriend knows how cool you are, also including another dozen of people.
I need to say, my boyfriend is a software developer himself. So we're doing this together, right? So in the evening, what we do is we write evals. It sucks, but that's how it is. And then one of the worst things is, like, essentially my boyfriend is now also my PO. It's weird.
Well, not exactly the perfect agile setup. I would take some minutes to actually let other people ask you questions, because mine will be probably going already in after the time session. I think Tara was raising their hand.
No. Go ahead. I didn't want to interrupt. Go ahead. Go. No, I'm fine.
Nice. Okay. Because what I am very curious about, especially when it comes to the potentials and the next steps, because you are very, very clear on what should have been done, what were the one-by-one things that should have been tackled. It is very impressive on how procedural you were with this process. At the same time, I would be very curious on what do you think about the models that are appearing when they have a certain vision capabilities in terms of screen share. We might have seen the latest releases on Google Flash when you're kind of talking to what is on the screen. There were also other models that are doing similar things. But for me, the best use case for something like this, because I personally don't really need to talk to my presentation or my architectures. Like, I don't really do that. But I can imagine that exactly in the gaming context, that can be a perfect fit. Have you had already the chance to have a look on those ones?
Yeah, definitely. So luckily, we don't need to rely on them right now because we have these game events that tell us a lot about what the game is currently doing already. So we don't need to rely on vision capability. We actually included a tool to get the current screenshot and then send it to GPT-4o because that also has vision capability and actually also is really good at that. But what we noticed is that in very few cases, this was actually needed. There's a few menus inside of the game where like you go into a trading menu, which is like a computer terminal that you can walk up to and then interact with and so on and so forth, where this would be useful. But this might actually also be more on the OCR side than on the actual image understanding. So we looked at it and we said, not right now. This is not the main focus that we currently have because the system already works and the advantage that we're going to get from this is not too large. But we're still on the lookout for new models. We're always testing. The first thing I do when I see a new vision model is I'm going to post a screenshot in it and let it tell me what it sees in the game, just to see how good these models get. One model that I actually really like because it has really good OCR capabilities and it's super small, so we can run it locally, is the Florence 2 model by Microsoft. The base model is super small and it has like, it can detect bounding boxes and so on and so forth. So yeah, I really enjoyed that and I definitely want to try it out at some point. But there's a lot of other things that we want to do. And like you said, like, yeah, we know a lot of the things that we want to do, a lot of the ways we can improve this. But yeah, time is an issue if you do this as a pet project. It could be a full-time job. It isn't. So we're just going to do it for 1 or 2 hours in the evening and then go watch TV or something.
Very, very cool, Luca. I think that we would be all curious if you could drop the link to the GitHub repository because I think the code is actually public, right? As far as I recall. So that I think would be helpful to others. And I really, really appreciate you sharing your journey with us. And now you can actually see the link in the chat. I will be happy if we will all clap to Luca using the reactions that we will meet. And I'm wishing you to have a wonderful evening. Maybe today without EliteDangerous, maybe with, who knows? Oh, and I see a lot.
Thank you so much.
Clapping. And I fully agree that that was amazing.